and there's also going to be parallel and perpendicular lines. So I'm going to do the evens of the study guide. And then what I recommend is you can do one or two things. You can, of course, take notes, follow along, which I highly recommend, and you should do that anyway, just so you can see where I got everything from. And then after I finish the review, then you should do this page here. And what I'll do is I will post the solution to this page so that as you're working through some things by yourself, you can be able to check and make sure you're on the right track. All right, so let's just jump into it now. Okay, so the first thing it asks us to do on number 2 on the Unit 5 study guide is to graph these two lines that are in the system. Okay, so one of them, and excuse the background noise, it's this is number 2 equals 15, and then we have another line in the system that is this one. Okay, so they want you to solve this one by graphing. So remember I told you the first step always is to put a star, convert each line into slope intercept, y equal mx plus b. Okay, so as you can see, the bottom one is already in slope intercept form, y equal, and then you have the 2x plus 4. It's this top one that's in standard form that needs to convert over to slope intercept. So I'm going to go ahead and get y by itself. Notice that if I'm taking the time to rewrite every problem again, guys, then it's the same for you. You know, it's really a matter of, I don't cut any corners, so make sure you don't. All right, so this one here is a positive 3/5 x minus 3. So the two equations that I need to graph is going to be this one right here, and then this one right here. Right, and I'm going to do a small sketch off to the side, and then let's figure out if we can find out the point of intersection. So here's my xy plane, and then I noticed that in this equation, 0, 4 is the y-intercept, and of course the slope here is 2/1, so I'm going to go from here up 2, and then over 1 to the right, so I'll be about right here. And this is a nice solid line going here. So there's my first line. Okay, now I'm going to go ahead in another color, and I need to graph this one. So I'm going to go to 0, -3. There's the y-intercept, and the address is to go 3 up and 5 to the right. So I'm going to go up 1, 2, 3, and then I'm going to run 5 to the right, which will be here. Now, one thing you notice about this one is if you keep elongating it, and then I keep coming a little bit better. I'll tell you what. See this popsicle. So it's a little bit better here. I'm going to retrace over it, so it's going to be not that neat. But you do see eventually, that's terrible, guys. This one will eventually cross. Okay, I got to go a long ways. All right, so again, in this case, you can't see it. Sorry about that. So again, I'm going to just try to stay along this plane here. And I'm going to come here with this one. Okay, don't want to make it work, but somewhere way over here in quadrant 3, these two intersect. So let's just now, when it happens like that and you can see your point of intersection, because again, that's why I tell you guys to draw the arrows, because these are infinite in both directions. So what I'm going to do now is set these two lines equal to each other to find what x coordinate they have in common, and then I'll come back and get the y coordinate. So let's do some scratch work over here. So I'm going to take the 2x plus 4, set it equal to this one. I'm trying to figure out what is the x coordinate where they are going to intersect, or they have the same value. I want to get rid of the 5 in the denominator. So before I do anything, I'm going to multiply every term by 5, just so I can get rid of my fraction. Okay, now I'm going to do my letters left, numbers to the right. Excuse me. So I got 7x plus 20 is equal to negative 15. Subtract 20 to both sides. And what do you know? 7x is equal to negative 35, so x is equal to negative 5. Now, between you and me, it doesn't look like way the heck over here would be negative 5. I'm not even sure why this is so catastrophe-like looking. I don't know what's going on. But whatever the case may be, maybe, I don't know, you would think they would kind of begin to cross a little bit more this way. Let me check one more thing. 1, 2, 3, 4, and then up to over 1. Yeah, I think one thing, if you notice, and that's what makes things get thrown off, that's why grid paper is so important, everyone, is notice how with these hash marks up here, they're so tight, like when I was doing my jumping, but see, these ones are a little bit more spaced out, so the scales on the directions are off, so that's why it looks kind of like this, I think. So grid paper is better, and I will switch over. But for now, let's just believe our math. We got negative 5 for x. Now I'm going to come back and plug in negative 5. Again, I can plug it into here in this equation, or I can plug it into this one. It doesn't matter, okay? All right, so now I'm going to decide to just do the top one. So let's do y is equal to 2, negative 5, and then plus 4. Y is equal to, that's negative 10 plus 4. Y is negative 6, okay? So the point of intersection is negative 5, comma, negative 6. This is the answer for number 1, okay? Now, if you want to just to make sure that you're completely correct, you know, if you have a graphing calculator or you can use decimals. So what I'm going to do in this case is I'm going to use this TI-84 just to show you that we're on the right track. So I'll come here, and one of our equations again was 2x plus 4, enter. And then the second one, I believe, was the what? 3/5 x minus 3. 3 divided by 5, x minus 3, enter. And then I'm going to graph these two. It's thinking. Now notice in my case, sorry about this, nothing happened. So what we're going to have to do is go to the window. And I can tell you right now that, see how we're at negative 10 for x, positive 10. We need to change our scale. Then regraph. Now we can see all of it. So there it is. And what do you know? So even though, and I want you to just see that, guys, look, mine's like way the heck over here because, again, my scale is not together. It should have been somewhere happening about right here. And so it looks very similar, but mine's way exaggerated. But that's okay. Like I said, that's why we know other methods to go around what's there. So now I'm going to figure out my point of intersection. So on the TI-84, second, and then I'm going to go to calc. I'm going to go to intersection, option number 5, and then I'm going to select the first line, press enter. It jumps down to the second line where the y-intercepts are, press enter. And then I'm going to guess, so I'm just going to walk over toward where I see the intersection point looks like it is. Just stop there as my guess, press enter, and then there's the answer, negative 5, comma, negative 6. So we are right. All right, that was our answer. All right, let's move on to the second one. All right, so now for number 4, and what I'm going to do is I'm looking for graph paper and I realize I don't have it, but I'm going to keep with the same method. So for number 4, they gave you these 2 lines in the system. So again, we want to get them in slope-intercept form. So this one here almost has y isolated by itself, but there's a times 3. So let's divide by 3 to this term, and this term. And again, I rewrite it again. Whoops, that's a y. My eye was looking at the x. Divide by 3 everywhere. So for this one, it's y equals 4/3 x minus 2. All right, that's that one. Now for this one, I'm going to go ahead and again, I'm trying to get y by itself. So let's subtract 8x from this side, subtract 8x from this side. And I think the one thing that gets a few students, okay, is remember you have to take that negative 6 and divide, by every single term. You do not want to leave this y negative. So take the sign with that coefficient everywhere. Y is equal to, again, you reduce your fractions. So this would be a positive 4/3 x, and this was a plus 5. Now, one thing I noticed, guys, within this particular problem, which is pretty neat, is that I noticed that the slopes are the same. And so, again, if you just make sure you stay on top of skills and things that we go over, because these slopes are identical, they are equal and the same, we already know that parallel lines have the same slope, right? So, therefore, this particular system does not have a point of intersection because they're parallel lines. So if I sketch this out super quick, this one has a y-intercept at 0, 5. Again, this is just a rough sketch. And I need to go up 4 and 3 to the right. So because I'm going to run out of room, I'm going to do the opposite. I'm going to go down 4 and 3 to the left. So I'm going to go down 1, 2, 3, 4, and then I'm going to run 3 to the left. So I'll be about right here. You count again, 1, 2, 3, 4, and then over 3. Okay, so one line looks something like this. And then the other one, the y-intercept is at 0, -2. And again, let's go up 4, 3 to the right. So 1, 2, 3, 4, and then we're going to go 3 to the right, which would be about right here. And then what do you know? If we had nice straight rulers, these two will just continue to run side by side, but they'll never cross. So this one has no solution. Sorry for the sound, it's a cartoon movie. All right, so does that make sense? So this one has no solution. There's no point of intersection because, again, the slopes are equal, which means they're parallel. They will never cross. And in this case, again, this was a disaster on the graphing, but the method that you use when it doesn't work out perfectly is you can set your two y's after you get it in slope-intercept form. Set the two y equations equal to each other, like I did here. I got rid of my fraction, and then when you solve, there's your x, and then go back and plug it into one of the y equations and get the y. This is the point of intersection. You can always use a calculator to check yourself. All right, so that is the graphing method. It should be number 6 on the study guide. We're doing the substitution method. Now, a lot of you guys said that you really like the substitution method, and I just played back part of the video and I noticed, so I apologize. I don't know what that ringing sound is, but we're just going to work with what we got, okay? So in this case, for the substitution method, you're substituting, which is pretty straightforward, right? It's like I want to, swap out, a particular expression for a variable. So what I mean is if y is equal to 5x minus 27, y equals y is the same as this expression. So that means that in this top equation, if y is equal to 5x minus 27, then that means I can substitute that expression right into there for y. So when I get ready to rewrite my equation and solve, I basically have 2x plus 3, and inside of here, I have the 5x minus 27, and then that's equal to 4. So there's the substitution. All right, once you plug in your expression for the variable, so then once you plug it in, now you do the distributive property, and then you combine like terms. So you got 2x plus 15x minus, and then I got to do some scratch work for 27 times 3. So from there, remote. So now I have 1, carry the 2. This is 6, 7, 8. That's 81. So this is negative 81 is equal to 4. And then we're going to combine like terms. So now when I combine like terms, I get 17x minus 81 is equal to 4. See that? Now I'm going to add 81 to both sides. So now I have 17x is equal to 85, and we got to figure out when we divide 17 into 85, how many times does that go in there? Now I'm going to just take a stab at it and say 5. And the reason why I did that so quickly is because I'm thinking to myself, 7 times what gives me where there would be a 5 in the ones place. So if I try 5, right, 17 times 5, let's see if I get 85. So that would be 35, carry the 3, 5, 6, 7, 8, yep. Goes in there 5 times, leaves no remainder. Great. So that means x is equal to positive 5. And now that I have x is 5, I still need to figure out the coordinate for the y coordinate, right? So now I'm going to take this 5, plug it into here, and then get the y coordinate. Because the whole point of this these skills with systems is, what is the point of intersection? Where is it that these two lines have the same coordinate or place where they have the same answer or same solution or same coordinate? So we got 25 minus 27, which is negative 2. So at 5, comma, negative 2, that's the point of intersection. And now, if you decide, am I right? Plug in these two values into both equations and see if you get the answer. Excuse me. Let's see if this gives us 4. So that is correct. All right, let's keep going. All right, so now let's look at the next one. Again, we're doing the substitution method. This is number 8 on the study guide. All right, now in this case, you notice that I have no y or x isolated by itself. A lot of you guys feel really comfortable getting y by itself, which is completely fine. Stick to what you know and what you're comfortable with. So, but build yourself individually to do it either way. So sometimes you can manipulate one of the equations and get x by itself. And if you, again, feel comfortable just getting y by itself, then do that. And the easier one to manipulate is this top one, because again, you would of course subtract the 6x over to this side, and then you would have negative y is equal to negative 6x minus 21. Remember, like I said before, you don't want that negative on that y value, so there's a negative 1 here. So let's divide by negative 1 to every single term. And now we have y is equal to positive 6x plus 21. So again, now that we know, y is equal to this expression, y is the same as that 6x plus 21, we're going to take that expression. Do not plug it back into the original equation. No, plug it, because it's a system, into the equation that you haven't manipulated. So we're going to plug in that 6x plus 21 for y in the second equation. So now we have 5x plus 3, but remember it was 3 times y, and again that y is the 6x plus 21. Set it equal to 17. And now the next step is to always do the distributive property. So now we have 5x, we have 18x, and then 21 times 3 is 63 equals 17. And now that the equation is all in terms of one variable, which is our x, then we can just solve for x, right? 18. So now we got 23x when you add those together, combine your like terms. And then, of course, remember I said letters left, numbers to the right. So we're going to leave our letter, the variable, here on the left of the equal sign. I'm going to move this 63 to the right, numbers to the right. But you have to change the sign and do inverse operation, because you don't want that guy living there anymore. You change the address, change the sign. So 23x is equal to 63 minus 17 is going to be 46. But it's going to be a negative 46. Because I got to subtract and keep the sign of the bigger number. When I divide 23 into negative 46, x is negative 2. Okay, so now that I have x is equal to negative 2, I'm going to plug negative 2 for x in right here and solve for y. Okay, so now I have negative 12 plus 21, y is equal to, and I want to say when I subtract these two, it's 8. No, 9, negative 9, positive 9. Yeah, 9. 12 plus 9 is 21. Okay, so the answer for me is negative 2, comma, positive 9. This is the point of intersection of those two lines using the substitution method. Okay, so this one I believe was number 8, and this one up here was number 6. If you want to make sure that you're correct, then once again, you could use the calculator and graph. So I'm just going to show this. I'm going to clear out the other one that I checked with the graphing method. And so one of the lines was this one. So let's put 6x plus 21. And the other one, unfortunately, I did not change it at all to be in slope intercept, because when you graph, you have to be in the y equal mode. So this one real quick, I'm going to do it. So it's y equal, it had been a negative 5x, then divide by 3. So I believe it's negative 5/3 x. And then I just divide 17 into 3, and I'm going to leave that as a fraction. Okay, let's see if I got that one right. Negative 5/3 x plus 17/3, enter. And then I'm going to graph. And my scale should be good. Whoa. Yeah. So as you can see, it's way up here in quadrant 2. And if you want to see something better, of course, you go to your zoom. We're going to zoom out. They're asking you, where do you want to zoom out? Well, I want to zoom out up here somewhere because I can't see what's going on up there. Enter. And it will literally reshift your scale and everything so you can see a bigger image of the picture. And now I could sit back and go to second calc again. I'm using the TI-84 Plus. This is one that I used a lot last year. So now I want to look for my point of intersection. So enter, it jumps down to the second line, enter, and now I have to guess. So I'm going to walk up about right here. I'm going to say about right there, I think my guess is, and hit enter. And it's going to spit out the answer, -2, positive 9, and that's exactly what we got. See, not too bad. All right, so now let's go to elimination. An elimination for some people gets, I have mixed reviews with elimination from you guys. Some of you say, I got it. Some of you say not so much because I didn't know that I could multiply to both equations, and yes, you can. The whole point of elimination is with elimination, you're trying to get rid of just one of your variables, your x or your y. So by any means necessary, like Martin Luther King says, right? Or I want to say, let me take that back. I think it was Malcolm X that said that, by any means necessary. So forgive me on the misquote. It was Malcolm X, not Martin Luther King, that said that. And then just kind of as a note, so what does that mean by any means necessary? It just means whatever it possibly takes to achieve whatever it is you're trying to go towards the goal of, right? So in this case, do you want to get rid of x? Do you want to get rid of y? So if you say to me, well, Ms. Bose, I want to get rid of x. Okay, great. We can get rid of x. But remember, you got to do two things to get rid of x. The objective when you sit back and do elimination is you want to get both coefficients, on the x or y, both coefficients to have the same multiple, means they have to have the same number, and you want one to be positive and one to be negative. So both coefficients to have same multiple, is the word same multiple, and one positive, one negative. So that means that if you want to get rid of x, well, the multiple they have in common is 10, but you want to have a 10x and a negative 10x. Well, it doesn't matter if you put the negative or positive or the top or the bottom. So in this case, I'm going to leave this one as the positive, but the bottom one, I'm going to get a negative 10. You see that? So I'm multiplying the top one by 5 because this is going to give me a positive 10x. But remember, I have to distribute this 5 not just to him, but to every term in that equation. And then you got to turn around and you want a negative 10x down here, and it has to multiply to every term. Okay, so we have 10x, 40y, 30, negative 10x, negative 40y, and then negative 30. Now what's interesting about this, and you look at your math again, because some of you guys do these like, oh my gosh, I must have done something wrong, or what happened, my x and y went away. Well, that's okay. You just look back over your math again and you say, no, this is a 10x, this is a 40y, this is a 60. I'm sorry, this is a 30. 30, and this is a negative 10x. This is a negative 40. This is a negative 30. And then you just look at it, and that's exactly what you have, because again, you were trying to get rid of x, but coincidentally, guess what happened? You are getting rid of x, y, and your constant. Now, a lot of people have been looking at this, and you guys tell me no solution, and that's incorrect. Remember, this is a true statement, therefore the answer to this one is infinite solutions. Okay, now the interesting thing is you should also see that, once you multiplied by those numbers, do you see how you got the same exact numbers? Well, then that means this is the same line, basically. That's it. So not too bad. It doesn't look like it would be that way, but it is. All right, let's go to the next one. This was number 10, I believe. So let's go to number 12. The next elimination that we have is this one. And the problem with this one is, you don't have them both in standard form. Remember, your x's and y's have to be stacked one on top of the other. So what's going to happen is, let's move this 2y over to this side so that, the x's are together on this side, but the y needs to come this way, and then that 1 will be left on the right side of the equal sign, just like that negative 4 is on the right side. So when we rearrange this, I'm going to rewrite the top one like it is. The bottom one, however, is going to change to this. All right, so now my x's and y's are stacked on top of each other. And then who do we want to get rid of, x or y? Well, in this case, let's get rid of y, okay? So I'm going to leave the x's alone. And so to achieve eliminating the y, I notice this one already has a negative 2. Well, I can make this one have a 2, but I want it to be a positive 2 if this one down here is a negative. So I'm going to multiply this top one by a negative 2, because remember, I know that negative 2 times, and this is a negative 1, a negative times a negative is a positive, and then 1 times 2 is 2. So when I do the distributive property through the first equation, I'm just going to rewrite it again right below here so my x's and y's are stacked. This is a negative 8x, a positive 2y, and a positive 8. Okay, and don't forget to pause the video if you need to see something, or play something back again if you need to. Now, once we got a negative and a positive here, well, now we need to cancel out the term we wanted to get rid of, and we're just adding down. So this is a negative 3x equals, and then this is a 9. When I divide by negative 3, x would be negative 3. When you divide both sides by negative 3. Well, now I still need y. So now, again, it does not matter how you do it. You could take this negative 3, you could plug it in here or here to get x, and in this case, I'm going to plug it in the top one. So rewrite the first equation with a 3 there, but be careful on this. What was y? Oh, I'm so sorry, I messed up. Fixing this. Messed up. I solved for x. My brain was thinking about y. Okay, so x is equal to negative 3. We got to plug it in right here or right here. Still going to use the top equation. So let's do 4 times negative 3. See, teacher can make a mistake. Just catch yourself and fix it. So this is negative 12 minus y equal negative 4. Add 12 to both sides because I'm trying to get y by itself. However, there's this negative in front of y. We'll combine those two for positive 8. But I got to divide by negative 1 because I don't want that y to be negative. So I got y is equal to negative 8 and x is negative 3. Okay, and the way you can check this is, again, you can use the calculator and put them both in slope-intercept. You could plug in the negative 3 and the negative 8 into here and here and make sure you get true statements. So I'm going to show you this because that's the end, guys, of graphing, elimination, and I've done substitution. And now we're going to move on to inequalities. But just to check and see if I got the right answer, we plug in negative 3. The y we said, that's what I wanted to show you guys, is watch that. You have a minus y. So I have the minus, and then our y was a negative 8, so we have a double negative, which becomes the plus plus. So this is negative 12 plus 8, negative 4, and that is a true statement. Negative 12 plus 8 is negative 4. So far I like that one works. Now I'm going to do the bottom one. 5 times negative 3 equals 2 times negative 8 plus 1. And this is negative 15. Negative 16 plus 1. Yep, negative 15 equals negative 15. So that has to be the point of intersection. All right, so I hope everything is going good for you guys in your understanding of that. Again, play back the video. I've done everything. Graphing, this is elimination here, substitution here, and then I did the graphic, which that was terrible. Okay, all right. So now let's move on to, and I just want to double check something real quick. I guess it's still screen recording. All right, so I'm taking care of number 2, 4, 6. All right, so one thing I did, hopefully, oh no, I just realized something. Give me 1 second, guys. Oh, this is the review. Whew, I was about to say, what? My numbers are completely different. I gotta go up here to the study guide, I apologize. So yeah, that was number 2, 4, I've done 6, 8. I figured there was two of each type of method. I think I did 10. Yep, that was 12 for elimination. Yeah. Uh-huh. And now let's get to some word problems. So let's look at number 14. I'm going to zoom in here. And we're just going to read it, and then I'll toggle back and forth to write down, and then we'll go to inequality. So just one thing to note is that I may put a word problem because I'm showing it now in this video, so you get some application. It could be a bonus question, but it doesn't hurt you. Okay, so let's look at 14. Jim sells hot dogs for $2.95 each, and he does steak sandwiches for $9.95 each out of his cart. During a busy outdoor festival, he sold this many items of food. He made $7,343.75, which is awesome. Good for him. How many steak sandwiches did he sell? All right, so let's go to the document camera. Okay, I'm going to capture a little bit of information in my brain to see if I can remember. Okay, so one thing we should see is that he's selling 2 items. He has, we'll do AS for steak sandwiches, steak sandwich, and I believe the other one was hot dogs. Okay. I may have to toggle back and forth. Okay, for the hot dogs, they were $2.95 each. So $2.95 times each. So for the number of hot dogs that he sells, someone's going to give him $2.95 per hot dog. For the steak sandwich, which is S, I want to say it was $9.95. Yeah, that number rings a bell. And because this information has to do with money, right? It's $2.95 per hot dog and $9.95 per steak sandwich. This is my money equation. Equation number 1. So then it makes sense that I got to figure out, well, how much money did he make? If someone's giving me $2.95 per hot dog and $9.95 per sandwich, and I made for that day $7,300 and I think it was 95. Let me go see. Yeah, $7,343.75, and then yes, I got the correct pricing of the steak sandwich and the hot dog. Okay. So now the last thing that they told us of information is he sold, I believe, 785 items. So hot dogs plus steak sandwiches was 785 items that he's purchased. I'm sorry, not purchased, sold. So that's how many things he sold total, but you don't know how many steak sandwiches and how many hot dogs, right? Yeah, let me just double check one more time that I had the right number of items. Oh my gosh, see? That's why I had to check. 985, not 785. 985. Okay, so let me change this up. 985. Okay, great. So this is all the information we need. We need the number of steak sandwiches, which is S. So guess what I'm going to do? I'm going to do the substitution method. So I'm going to get, in this case, I want S. So I'm going to get this equation in terms of H. So H is equal to, do you see how I got 985 minus S? I just moved this S over to this side, and H is by itself. Now that I know H is equal to the total amount of items, 985 minus the number of sandwiches, steak sandwiches, that's going to be the number of hot dogs. But when I plug this expression in here, way over here for H, what's going to happen when I do my substitution is I realize that, oh my goodness, the h is actually going to be gone and everything is in terms of s. And now that that happens, I can solve for s. So I'm going to take the 295 and I'm going to multiply it through the parentheses. Everything will be in terms of s. Now in this case, see, I wouldn't be that cruel to you on a problem like this. This is when you use a calculator on. The numbers are big. So let's do 2.95 times the 785. We get 2315.75. We'll write that right here. 2315.75 minus. And then when I multiply this and this, it's just going to be a negative 295s plus the 995s equals 7343.75. See, everything's in terms of s. Now I'm going to combine like terms, which is here and here. And 995 minus the 295 is going to be $7. That's 7s right here. And then don't forget I had this value here. I'm going to go ahead and move this to the other side. So I'm going to subtract 231.575 over to this side. And that's a 7. And then when I do my math here, I get 7343 minus, it comes out to 5,028. And then the last thing is to divide by 7. Let's see how many steak sandwiches that he got. So he actually sold 718. And now some people are responsible about this 0.39, 0.29, or 0.3. Well, this is not money. This is the number of items. So you got to round down. I want to say you can't 0.2, 0.3, round down instead of up. So he sold 718 steak sandwiches. That's what I think. Put 718. And if we want to, you could always go back and get hot dogs. And of course we can get hot dogs because we will just take that value and subtract it away, and that's how many hot dogs there were. And even though there's a little bit of that decimal in the way we're rounding, we can plug those numbers in and then see if we get as close to that value as possible. All right, so that's just an example for a word problem. And let's look at one more. Okay, now if I move on to the next one, number 16, let's see how similar this one is. Ethan, he makes $6 per hour mowing lawns, but he makes $7.50 per hour bagging groceries. So he has 2 jobs. Last week, he made a total of only $129. The difference between the number of hours bagging groceries and the number of hours mowing lawns was 10. So the difference of his hours of working one to another was 10. How many hours did he spend just mowing the grass? Okay. Let me capture down some information so I don't waste time in the video. Okay, and the difference between the number of hours doing groceries and mowing the lawn is 10. All right, let's see if I get this right. So I said he makes $6 every hour he's mowing grass. He makes, oops, I should add. He makes $7.50 per hour every time he's bagging groceries. He made a total of $129. Notice that majority of the time with word problems, there's always a money equation, usually. And then the other one has to do with something with, hours or items or something. So again, $6 when you mow grass every hour, $7.50 when you bag groceries every hour. That's how much money he got paid for the week. And then it said the difference between him bagging groceries and mowing grass was 10 hours of difference. All right, so here we go. So in this one, same thing, I'm gonna do substitution. They wanted to know how many hours did he spend doing the mowing. So I'm gonna get G by itself. So G is equal to, in this case, 10 plus M. And I'm gonna plug in this for G here. And when I do my substitution, I'll notice that everything is in terms of M. I hope this is becoming a little bit more easier. for people to understand. Hope these videos are helpful. That's why I asked y'all to watch them. All right, so we got 6m plus 75 plus 7.5m equals 129. If you combine like terms, that's 13.5m. And then I'm going to go ahead and I got to subtract 75 over to this side. For the sake of time, I'm moving a little bit quicker. So 129 minus 75, guys, was 54. And when I divide 54 by the 13.5, I got a 4. So he spent 4 hours mowing the grass. Okay. So bagging groceries then must have been 14 hours. And I know that because 14 minus 4 would be 10. Okay. So that's word problems. Not too bad. Substitution method seems to be really easy and a better way to solve. All right, so now let's keep going. Let's get to inequalities. Now remember, because inequalities I think are straightforward, but my main focus is to do the system ones. So I'm actually going to jump to number 20 here. But remember, this one's pretty easy, right, guys? For number 19, you would just go to -3, which would be over here, -1, -2, -3. This is a vertical solid line. Put a vertical line through that -3. Notice from left to right, it says y is what? Greater than and equal to. So I want to shade everything over here where x would be greater, would be to the right side of the -3. For this one, number 18, put it in slope-intercept form. So subtract the 2x over to this side, divide by -3 everywhere. Remember, you would have to flip this inequality symbol, and then you again plot your y-intercept, do your rise over run, and then shade. But I know you're kind of like, well, Miss Posey, can you do it? But again, this one's just one line. It's really easy. But let me show you now with number 20. And let's see how you feel. If not, like I said, message me and I can do another one. But I am going to post the answer key. All right, now you don't have to worry about word problems with inequalities. I'm not going to do anything with a word problem on that. Okay, so here we go, last problem. Let me see where I'm supposed to click right here. All right, so for this last one here, this is a system of linear inequality. So they gave us 2 lines and they were being nice. So I may do 21. This one is already in slope-intercept form. Both of them are. Okay, so again, this is a sketch. So the y-intercept is -2, and I'm going to try to make sure my spacing is pretty decent. 0, -2 is the slope-intercept. I'm sorry, y-intercept. The address is up 3, 1 to the right. So from here, I'm going to go 1, 2, 3, and then 1 to the right. And then remember, because this says y is less than, there's no line under here. So I'm going to put a dashed line going through these 2 points. And then for the other one, the y-intercept is at 0, 3. So I'm going to go here, 2, 3. And then I'm going to go, again, this is like having -1 over 1. So let's go 1 down, and then 1 to the right. And then I'm going to do it again. 1 down, and then 1 to the right. My son. And now, again, this is also a dash line. So I'm going to put a dash line here. No, son. No, don't mess it up. No. It ain't on. It ain't on the microphone. What did I do? Not yet. Shh. I'm in the video. Shh. Oh. Okay. Now, I didn't do the shading yet. So let's read from this one again. Y is less than. So for this solid black line, I'm going to put a less than. That would be everything less than over here. And then this one is saying y is greater than. So the blue one's saying greater than. So actually this right here is the solution set, because that's where the black and gray overlap. Another thing, again, always quoting and loving what Chloe said in class, I should have done open circles. So these actually should be open circles on both of those lines, but I won't penalize you for that, but it should be an open circle. All right, that's a linear inequality. Now to be nice, I'm gonna do one more. So let's look at 21, because at least on 21, you notice again, we have to do the extra work where y is just not by itself. All right, here we go. So for this one, get them in slope intercept. So for this one, I'm gonna do negative y greater than or equal to, and again, I'm subtracting 2x over here, and then this is just a nothing, 0. So this is like going to be there. I don't have to put the 0. But when I divide by negative 1 to both sides, it's going to flip. Y is not going to be greater but less than or equal to positive 2x. That's the top one. The bottom one is going to be y less than negative 3x plus 5. So now when I sketch my two lines, remember that this is 0 back here, so the origin is the y-intercept. And the address is up to 1 to the right. So we're going to go to 0, go up to 1 to the right, and we would be here for 0, 0, and then right here. And that line, notice that it's a solid one. And then this says again, y is what? Less than or equal to. So I'm going to shade less than. All my y values are less than here. And then on the other one, I'm going to get another color. And this one, the y-intercept is at 5. So 1, 2, 3, 4, 5. And then I'm going to go down 3, 1 to the right. So from here, let's go 1, 2, 3, 1 to the right, which would be again an open circle. And that's fine. And this was dashed. Alaric. Okay. And then shading, y is less than. So when I do my red, and I look at red and blue, that's their overlap or common solutions. All right, guys, that ends up with everything, okay? The only thing I didn't touch on is parallel and perpendicular lines. And so what I'm going to do for that, possibly, again, this is systems of linear inequalities. This is 20 and 21. What I can do is just post some notes on parallel and perpendicular. All right, guys, see you later, and make sure you study hard. Remember, pre-AP, your test will be on Thursday, and then for Algebra 1, your test will be on Wednesday.